in NASA scientist, Amitabha Ghosh, who joins us now live from Washington. It's good to have you on. You know, you and I, we've actually talked several times over the past years, talking about sort of various historic and important space missions. We've had you on previous SpaceX launches. Talk to us about what your feelings are when you look at this particular mission with the first Turkish astronaut on board heading up to the International Space Station.
So it's fascinating. If you think of, you know, I was born in 70 and in 1969, the space business was really, there were two players and it was very, very hard to go to space. And just now what happened is the Axiom 3 is like a middle layer. They organize these trips on a private entity. So you could, if you or I had $55 million, we could also go to space. Maybe 10 years later, you would need $100,000. Maybe 20 years later, you will need $10,000. Who knows? So we are in this state of democratized space because of costs coming down, because of technology becoming easier. And the third thing is there is huge public interest. See, space motivates like nothing. People say that, you know, a lot of the Silicon Valley companies happen because of all the human resources that were trained and motivated during the Apollo era in the 70s. So here, the fact that Turkey is right now coming into the Space Club is huge. It's a huge deal psychologically. Think of how many children might be watching this. Think of how many, you know, so there is a huge, the space has a huge motivator. It's, you know, you're actually trying to think of how we are placed in the universe, these profound questions, and this is away from, you know, all the negative news that is bombarded, you know, because of, you know, things happening around. So this is something positive which helps people get motivated, come around, and another thing that why all this is being possible is some of the innovation. And what was this incredible innovation? See, previously, you saw the launch of the launch vehicle, right? And these things used to be destroyed. And now Falcon 9, Elon Musk found a way for them to be reused. So guess what? The cost of spaceflight just went down by maybe 95%. So it's a huge deal, I think.
I mean, also tell me, I mean, Pat and I were talking about some of the advancements in the technology. You know, the cell phone that I hold in my hand, he was saying actually has more computing power than some of the rockets that were used during the Apollo mission. Obviously, this plays a huge part in terms of what we're able to do today.
Absolutely. See, if you compare the first Mars rover, 1997, Mars Pathfinder, this has way much more memory, and it actually has all the subsystems that the rover had. It has the power subsystem, it has something for imagery, and in addition, it also has AI. It can do face recognition. So, and how expensive is it? A cell phone? You could probably buy a cell phone for $100. So it's $100 to $1,000 window. So the accessibility of technology is what is also making it possible. You can actually send a cell phone from space and in a CubeSat, and you can get pretty good results. So, and the other thing is this can also be done by, there are school teams all over the world who are trying to set up CubeSat. If you remember, normal people can go to a NASA website where all the data is stored and do discovery. So occasionally we have amateurs finding asteroids. If you remember, one of India's missions, it was destroyed, but an amateur engineer found the place where it rests finally. So all this means that there is much more public participation, much more public interest. If you think of your TV station, right now, I think an incredible amount of people are watching this. So this is because of the huge public interest and the public involvement.
Amitabha, talk to me about what you think of, I know that you probably had a chance to look at some of the experiments that are being conducted on this Axiom 3 mission, 30 in total. But when you look at specifically the ones that have been passed on by some of the Turkish universities and the research institutions for Alper to conduct and to oversee, a lot of them have to do with sort of microalgae and how they perform or or near zero gravity, the use of artificial intelligence. This is some fascinating stuff. I mean, even for a person who doesn't know that much about space, but also very excited to actually see that we're going to see some real life implications, you know, maybe a half decade or a decade down the line in terms of making our lives easier, more efficient, more pleasurable.
Right. So a lot of what we do on the International Space Station has to do with, one, microgravity. For example, if you have cancer cells, do they behave differently in microgravity? Well, that would be a real revolution. So there are a lot of experiments in microgravity that we do. So there are certain things. Can it be done better in microgravity, more efficient? Can it have a positive result? That is one. And two is, a lot of the research goes on to how can you make humans survive in microgravity? So that's a very big challenge. You know, if you say for anybody who broke his leg and it was in a cast for, I don't know, 2 months, you lose all the muscles. So here, when the astronaut comes back after maybe 2-3 months, then there's a huge muscle loss. So how do you reverse that? How does the eye has you know, there's fluid pressure that is different in space. Your bones lose mass. So if you were to go to Mars, that would take 6 months to go, 6 months to come back, and say 6 months to stay, 18 months. How are astronauts going to survive that? So there are two types of muscle, and as you said, the results are not going to be visible tomorrow. A lot of the research is serendipitous. Serendipitous means it is accidental. But in the end, if you try different things, it is possible that something will come about sometime a decade, as you said, away.
Okay, Amitabha Ghosh, thank you very much for joining us here on TRT World's special coverage as we watch this SpaceX Dragon 9 rocket being, as it heads towards the International Space Station. Let's